Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, today we are going to discuss trends in first ionization energy of period 3 elements. You people have studied in previous classes about ionization energy. Ionization energy is the energy required to remove the most loosely held electron from 1 mole of gaseous atom to produce 1 mole of gaseous ion. Like this is element and it is converted into its cation by removal of 1 electron, and for this the amount of energy required is known as ionization energy. And if it is the first electron that has to be removed, then the energy known as first ionization energy. Element or atom has been converted into its cation. First ionization energy depends upon number of factors like atomic size, nuclear charge, screening effect, and nature of orbitals. First of all, unit of ionization energy is kilojoule per mole. Ionization energy is measured in its unit kilojoule per mole. Now, going towards its trend from left to right in period 3, we come to know that ionization energy is going to increase from left to right in a period, and this increase is because as we move along the period there is successive increase in nuclear charge, that is nuclear hold is going to increase on the outermost electrons. As a result, there is a decrease in atomic radius and same shell is used, and same shell is going to be filled at every step. Because of increase of nuclear charge and decrease in atomic radii, outermost electrons are more closer to the nucleus. Now nuclear hold has increased on the outermost electrons, and you have to provide more energy to remove the outermost electron. As a result, ionization energy increases. More energy is required, that is more ionization energy is required, that is its value has been increased along a period. This is a regular increase, that is from left to right ionization energy value increases. Cleared? Now there is some irregular trend in period 3, and this irregular trend can be studied in the values like period 3: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon, and here are their values. Sodium has 496 kilojoule, magnesium 738, aluminium 578. Now you can clearly say that there is a irregular behavior in magnesium and aluminium. Aluminium should have more ionization energy than magnesium, but you can see the reversal case. Similarly, you can also observe the same irregular behavior among phosphorus and sulfur. Now, what is the reason behind these values? Before explaining their reason, I am going to tell you something that I am going to explain some orbitals properties. There are some type of orbitals which are known as completely filled orbitals. These orbitals are known as completely filled whose number of electrons are completely filled according to the rule. Like s orbitals have maximum 2 electrons, so it is completely filled. P orbital have maximum 6 electrons, so it is completely filled. And same d orbitals can maximum occupy 10 electrons, so it is completely filled. F orbitals can maximum occupy 14 electrons, so it is completely filled. These orbitals are known as completely filled orbitals. Now there is a category in like s electrons have 1 electron only, and it can maximum occupy 2 electrons. 1 electron means it is half filled orbital. P and P3 means that P orbitals have only 3 electrons. ND5, d orbitals have only 5 electrons, and NF7, f orbitals have 7 electrons. As you people can see that these orbitals have half of their total electrons. Half of their total electrons. From the above you can clearly see it. These orbitals having half number of electrons are known as half-filled orbitals. Now, there is an other category known as partially filled orbitals. These orbitals are like n, if we are talking about p orbital, then np1, np2, np4 and np5. These are regarded as the partially filled orbitals, means orbital electronic configuration not in completely filled and not in half filled orbitals. Similarly, in d orbitals, nd1 to nd4 and then nd4 to nd and d4, these are also partially filled orbitals. Then f में NDF to NF6 and NF8 to NF13. These electronic configuration other than half filled and completely filled, it is regarded as the partially filled orbitals. According to a theory, completely filled orbitals and half-filled orbitals are more stable. So we required more energy to remove electrons from their shell, and so their ionization energy value increases. This concept has been used in your book here, like magnesium has compared to aluminium. You can see electronic configuration of magnesium is 1s2, 2s2, 2p6 and 3s2. That is 3s2 means completely filled orbitals, and when it is compared with the aluminium 3s2, 3p1, that is it is half filled. So more energy is required to move electrons from completely filled orbitals, that is magnesium, so it has more ionization energy values. Got it? The next is phosphorus and sulfur. Phosphorus electronic configuration is 3s2, 3p3, and in sulfur electronic configuration is 3s2, 3p4. You can see that phosphorus is half filled and sulfur is partially filled. So ionization energy of phosphorus is more than sulfur, as half filled orbitals are more stable than partially filled orbitals. Similarly, from your diagram you can see that in third p block elements, first ionization energy increases along the period and decreases along the group. I hope so you people have clearly understood this. Thank you.